Two engineers were digging on an old farm when they hit something that shouldn't exist. But here's the thing. This machine from 1944 was about to breathe fire for the first time since World War II ended. This is the story of what happens when you refuse to let history die. The Henderson farm sits on 340 acres of Iowa soil that's been worked by the same family since 1887. 4 generations of corn, soybeans, and memories pressed into the earth. In the spring of 2023, the family decided it was time for renovations. They hired 2 civil engineers, Mike Patterson and James Chen, to assess the foundation of the old equipment barn before tearing it down. What they found would change everything. They were about 3 feet down when the excavator bucket hit something solid. At first, Mike thought it was bedrock or maybe an old foundation, but the sound was wrong. It was metallic. They stopped the excavator immediately and started digging by hand. What emerged from the Iowa clay was something that hadn't seen daylight since 1946, a wheel, but not just any wheel. When they saw the boiler and the piston assembly, they knew exactly what this was. This was a portable steam engine, agricultural class, probably from the 1940s, and it was complete. Over the next week, they carefully excavated the entire machine, 12 feet long, 8 feet tall, over 4 tons of cast iron, brass, and steel. It was a giant, and it had been sleeping under this farm for 80 years. The maker's plate told the first part of the story. Harrison Machine Works, Indianapolis, Indiana. Model Type 40, serial number 1847, year of manufacture 1944. In 1944, while American soldiers fought in Europe and the Pacific, machines like this one kept the home front running. They were the workhorses of American agriculture, powering threshing machines that separated wheat from chaff, driving sawmills that cut lumber for barns, pumping water for livestock, generating electricity for farmhouses that were still decades away from power lines. These weren't toys. A 40-horsepower steam engine could do the work of 40 horses, or 80 men. In an era when every able-bodied man was needed for the war effort, these machines were worth their weight in gold. But if these machines were so valuable, why would someone bury one? After they found the engine, Martha Henderson went through her grandfather's papers. He kept journals, very detailed, and in his 1946 journal, there was an entry dated November 3rd. It read, "Buried the old iron horse today. John wanted to sell her for scrap. Says we need the money and the diesel tractor is better anyway. But I couldn't do it. Too many memories in that metal. She got us through the Depression. She got us through the war. She deserves better than the scrap heap. Maybe someday someone will dig her up and remember what she meant." Her grandfather, William Henderson, had made a choice. Rather than watch his faithful machine be melted down for scrap metal in the post-war steel shortage, he buried it like a pharaoh, preserved for a future he'd never see. And now, 77 years after William Henderson buried his iron horse, 2 engineers stood before it with an impossible question. Could they bring it back to life? Most people would look at 4 tons of rusted iron and see scrap metal. Mike Patterson and James Chen saw something else entirely. The first thing you check on any steam engine is the boiler. If the boiler's compromised, if there are cracks or serious corrosion, the whole project is dead on arrival. A failed boiler isn't just broken machinery. It's a bomb. They spent 3 days just on the initial assessment. Every rivet, every seam, every inch of metal that would eventually hold superheated steam at 100 pounds per square inch. What surprised them was how well preserved it was. The clay soil in Iowa, it's dense, low in oxygen. It basically created a sealed environment. Yes, there was surface rust, but the structural integrity was remarkable. The assessment continued. The boiler had surface rust, but no visible cracks. Rivets intact, promising. The pistons were frozen solid from decades of immobility, but complete. The cylinder walls showed no scoring. The flywheel was 800 pounds of cast iron. Bearing seized, but the wheel itself was perfect, not a crack, not a chip. The smokestack was bent from the weight of soil, but salvageable. The gauges still had the original pressure gauge attached. Steam whistle still in place. The drive system, Belt pulley, eccentric drives, governor mechanism, all present, all frozen, all waiting. After 3 days of assessment, Mike and James reached a conclusion that seemed insane to everyone who heard it. They thought they could make it run. Martha Henderson thought they were crazy. This thing had been underground since before she was born. How could it possibly work? But here's the thing, people don't understand about these old machines. They were over-engineered. The tolerances were tight. The materials were high quality. And, most importantly, they were designed to be repaired. Every part could be disassembled, cleaned, fixed, and reassembled. You can't do that with modern equipment. A modern tractor has computers, sensors, proprietary software, and parts that are designed to be replaced, not repaired. This steam engine had none of that. What you saw was what you got. Fire heats water. Water becomes steam. Steam pushes pistons. Pistons turn a wheel. No electronics. No plastic. No planned obsolescence. Just iron, brass, and the laws of thermodynamics. But understanding how it should work, and making it actually work after 80 years underground, those were two very different things. They made a list of everything that needed to happen before they could even attempt to fire it up. The list had 47 items. Some were simple, clean this, oil that. Others were complex, pressure test the boiler, re-rivet failed seams, source period correct materials. They estimated it would take 3 to 4 months of weekend work. They were wrong. It would take 6 months. And every single one of those months would test their skills, their patience, and their belief that some things from the past are worth saving. But first, they had to wake it up. The first step in any restoration is understanding what you're actually working with. And you can't do that until you can see the metal. For 3 weekends, Mike and James pressure washed every surface. 80 years of Iowa clay, rust, and organic matter came off in rivers of brown sludge. And as the grime washed away, the machine began to reveal its secrets. Under the rust, they found traces of the original paint. Harrison green, they called it. This beautiful forest green with black and red pinstriping. Someone had taken pride in this machine. But the most remarkable discovery was the instruction plate, still riveted to the side of the boiler, still legible after nearly 8 decades underground. The instructions read, fill boiler with clean water to sight glass. Build fire gradually with kindling, then coal or wood. Allow 30-45 minutes for pressure to build. Do not exceed 100 pounds pressure. Oil all moving parts daily. Drain boiler completely when not in use. These instructions were written for farmers who might never have seen a steam engine before. Clear, simple, respectful. It reminded them that the men who built this machine wanted it to last. They wanted people to be able to use it and maintain it. That's a philosophy we've lost. As the cleaning continued, more details emerged. The serial number, the horsepower rating, the manufacturer's address in Indianapolis, a factory that had closed in 1957. Mike and James researched the Harrison Machine Works. They found that only 200 of these Type 40 engines were manufactured in 1944, the last year of production before the company switched to diesel engines for the post-war market. Of those 200 engines, they could only confirm the existence of 12 survivors. Most had been scrapped. Some had been destroyed in accidents. A few were in museums, no longer operational. This one, serial number 1847, might be the only one that could still run. The biggest challenge wasn't rust, it was immobility. A steam engine works through motion. Steam enters a cylinder, pushes a piston, turns a crankshaft, spins a flywheel. But this engine hadn't moved in 80 years. Every bearing, every bushing, every sliding surface was frozen solid. They started with penetrating oil, gallons of it. Every day for 2 weeks they'd come out and apply more oil, let it seep into the microscopic gaps between metal surfaces. Patience became their most important tool. Modern mechanics are used to impact wrenches and power tools. But with a machine this old, force would only cause damage. They used heat to expand the metal. They used oil to lubricate. They used time to let chemistry do its work. And after 2 weeks of daily treatment, they attempted to move the first piston. Nothing. They didn't give up. More oil, more heat, more patience. And then, on day 16, it moved. Just an eighth of an inch, but it moved. Mike and James looked at each other like they'd just witnessed a miracle. Because in a way, they had. That piston hadn't moved since 1946, and now it was alive again. That first movement was the breakthrough they needed. Over the next 2 weeks, they freed every piston, every valve, every moving part. Each component was removed, cleaned, measured, and inspected. The tolerances were remarkable, machined to within thousandths of an inch, even by 1944 standards. The quality of the machining was better than a lot of modern manufacturing. These parts were made to last 50 years of daily use. They were made by craftsmen who took pride in their work. Everything they'd done so far would be meaningless if the boiler couldn't hold pressure. This was the moment of truth. A hydrostatic test is simple in concept. You fill the boiler completely with water and pressurize it. Water doesn't compress, so if there's a weak point, it'll leak water instead of exploding with steam. It's safer than a live steam test, but it'll tell you everything you need to know. They filled the boiler with 50 gallons of water. Then they sealed every opening and connected a hand pump to pressurize it. The target was 100 psi, the maximum operating pressure. But they'd be happy if it held 60 psi, the minimum needed to run. At 35 psi, they found the first leak. They expected leaks. 80 years underground, thermal expansion and contraction. Rust. It would be a miracle if every rivet was still perfect. They marked each leak with chalk and continued pressurizing. At 60 psi, they had identified 7 small leaks, all at rivet seams, all repairable. At 100 psi, the leaks were still small and no new ones appeared. The boiler held. When that gauge hit 100 and held steady, Mike felt like they'd just won the lottery. The boiler was sound. This project was actually going to happen. Now came the delicate work of re-riveting the failed seams. They used period-correct techniques, heating rivets until they glowed red, driving them through the holes, hammering them tight while still hot. It was the same process that had been used in 1944, the same process that had built battleships and bridges and locomotives. After repairs, they tested again. This time, the boiler held 100 psi with no leaks. The heart of the machine was sound. Now they could bring it back to life. A steam engine is a symphony of moving parts, and every single one of those parts needs lubrication. Mike and James spent 2 full weekends doing nothing but oiling. They used period-correct steam cylinder oil, a special formulation that could withstand the heat and moisture of a steam environment. Modern oils would break down in a steam engine. You need oil that's designed for high heat and constant water contamination. Fortunately, there are still companies that make steam cylinder oil for historical restorations and steam locomotives. With everything cleaned, repaired, and lubricated, reassembly began. Each piston was carefully inserted into its cylinder, the fit so precise that it moved smoothly but with no perceptible gap. Connecting rods were attached to the crankshaft, the pins and bearings moving freely now after their long sleep. The valve gear, the complex mechanism that controlled when steam entered and exited each cylinder, was reassembled with watchmaker precision. And then came the flywheel. 800 pounds of cast iron, 6 feet in diameter, the mechanical heart of the engine. It took 4 men and a chain hoist to lift it into position. When it settled onto the crankshaft with a satisfying clunk, everyone present felt the significance of the moment. When Mike spun that flywheel and felt it turn smoothly, felt all those pistons moving in perfect synchronization, he got chills. This machine was ready. After 80 years, it was ready to run. An engine needs more than just mechanical components. It needs a firebox, a smokestack, water supply, and instrumentation. The firebox needed new fire brick, special refractory brick that could withstand the intense heat of a coal or wood fire. They sourced brick from a demolished steel mill, brick that had been made in the 1950s using the same techniques as the original. The smokestack had been bent by the weight of soil. They carefully straightened it using hydraulic jacks and heat, then welded a crack that had formed during the burial. The water system needed restoration. The original hand pump that fed water into the boiler was seized, but after disassembly and cleaning, it worked perfectly. The gauges were cleaned and calibrated. The pressure gauge was still accurate, a testament to the quality of its manufacture. The water level sight glass was cracked and had to be replaced with a piece sourced from a steam locomotive restoration supplier. And then came a debate: coal or wood? Historically, this engine would have burned coal. That's what most farmers used in the 1940s. But coal is hard to source now, and it's dirty. They decided to use hardwood, oak, and hickory. It burns hot, it's cleaner, and it's what William Henderson probably used during the war when coal was rationed. They split 2 cords of oak and hickory, seasoned wood that would burn hot and clean. In the final week before the first fire, they added the finishing touches. The flywheel was painted Harrison green, the boiler was painted black. The brass fittings were polished until they gleamed. It looked like it had just rolled off the factory floor in 1944. The final inspection checklist had 47 items. Mike and James went through every single one. Boiler pressure test, check. Lubrication, check. Valve timing, check. Safety valve, check. Water pump, check. Firebox, check. Smokestack, check. Gauges, check. Every item was checked. The engine was ready. Now came the moment they'd been working toward for 6 months. The moment that would prove whether all their effort, all their patience, all their belief in this old machine had been justified. It was time to light the fire. April 15, 2024, 6 months after the discovery, 78 years after William Henderson buried his iron horse. Word had spread through the community. The Henderson family was there, 3 generations, including Martha and her brother Robert, who at 75 years old, was the last person alive who remembered the engine running. Robert was 5 years old the last time he saw this engine run. It was 1945, right after the war ended. His grandfather let him ride on the platform while he operated it. He remembered the heat from the firebox, the smell of the steam and oil, the sound of the whistle. He never thought he'd experience that again. Mike and James had been up since 4 a.m., triple-checking everything. This wasn't just about making an engine run. This was about honoring a promise made 78 years ago by a farmer who believed his machine deserved better than the scrap heap. Safety preparations were in place. Fire extinguishers, water supply, a clear perimeter. Despite their confidence in the restoration, they were about to create 100 pounds of pressure in a boiler that hadn't been fired in 8 decades. Respect for the power of steam was paramount. At 6:47 a.m., Mike Patterson placed the first pieces of kindling in the firebox. He built the fire the old way: newspaper, then kindling, then small pieces of oak, arranged to allow airflow. The match struck. The flame caught. For the first time in 78 years, fire burned in the belly of this machine. Smoke rose from the smokestack, thin and white at first, then thickening as the fire grew. As the fire established itself, larger pieces of wood were added. The firebox temperature climbed. While Mike tended the fire, James operated the hand pump, filling the boiler with 50 gallons of water. The sight glass showed the water level rising to the proper mark. Now came the wait. It would take 30 to 45 minutes for the fire to heat the water enough to generate steam pressure. As the minutes passed, more people arrived: neighbors, local historians, a reporter from the county newspaper, a videographer from the State Historical Society. Everyone wanted to witness this moment. All eyes were on the pressure gauge. Inside the boiler, the water temperature climbed. 150 degrees, 180 degrees, 212 degrees, the boiling point. At 7:23 a.m., 36 minutes after the fire was lit, the first wisps of steam escaped from the valve stems, and the pressure gauge needle moved. The crowd noticed. A murmur of excitement rippled through the gathering. The needle climbed steadily. 5 psi, 10 psi, 15 psi. Mike fed the fire, building the heat. The smokestack now poured thick black smoke, the signature of a steam engine working hard. 30 psi, 40 psi, 50 psi. James walked around the engine, checking every fitting, every valve, every seal. No leaks. The repairs had held. At 7:41 a.m., the pressure gauge reached 60 psi, the minimum operating pressure. Mike and James exchanged a look. This was it. Mike's hand moved to the throttle valve, the valve that would admit steam into the cylinders, and, if everything worked, bring this machine back to life. The crowd fell silent. Even the birds seemed to stop singing. Mike turned the valve. Steam rushed into the cylinders with a hiss. For a moment, nothing happened. And then, the flywheel shuddered. The pistons moved, slowly, reluctantly, fighting 78 years of stillness. The flywheel completed one revolution, then another, faster this time, then another, momentum building, and suddenly the engine found its rhythm. The pistons moved in perfect synchronization. The flywheel spun smoothly. The connecting rods danced their mechanical ballet. The crowd erupted. Robert Henderson wept openly, the sound of his childhood rushing back across 8 decades. Martha held her brother, both of them crying, both of them connected to their grandfather in a way that transcended time. Mike and James embraced, 6 months of work validated in this single moment. The engine ran, smoothly, powerfully, as if it had never stopped. Mike continued to build the fire. The pressure climbed, 70 psi, 80 psi, 90 psi. The engine speed increased. The governor mechanism, designed to maintain constant speed, engaged automatically, a testament to the precision of its engineering. At 100 psi, the engine settled into its designed operating speed, 120 revolutions per minute, smooth, steady, unstoppable. And then James pulled the steam whistle cord. The sound that emerged was primal, powerful, a sound that hadn't been heard on this farm since 1946. It echoed across the fields, across the years, across the generations. Robert closed his eyes, smiling through tears. That sound, that exact sound. He was 5 years old again, standing next to his grandfather. His grandfather was smiling, proud of his machine. And now Robert understood why he couldn't let it die. But the ultimate test wasn't just making it run, it was making it work. They positioned a portable sawmill, the kind that would have been powered by engines like this in the 1940s. A log was placed on the carriage. The belt tightened. Power transferred from the engine to the saw. The saw blade spun up to speed. The log was fed into the blade. The saw cut through oak like it was butter. Fresh cut lumber emerged. The smell of sawdust filled the air. The engine didn't falter, didn't slow. It delivered its full 40 horsepower as if it were 1944, and there was a war to win and a farm to run. The engine ran for 2 hours that first day. People took turns operating it, feeling the heat of the firebox, the vibration of the pistons, the weight of history in their hands. Black smoke poured from the stack, not pollution, but a signal that said, we remember, we preserve, we honor what came before. As the sun set on April 15, 2024, the Harrison Type 40 serial number 1847 breathed fire for the first time in 78 years. And in that moment, William Henderson's promise was fulfilled. Someone had dug it up. Someone had remembered what it meant. After the crowds left and the fire was banked, Mike and James sat on the platform of the engine, exhausted and satisfied. They didn't speak for a long time. They didn't need to. They both understood what they'd accomplished. This wasn't just about fixing an old machine. It was about something deeper, something that resonates especially with men who remember a different era. We live in a world of planned obsolescence, products designed to fail, devices that can't be repaired, technology that's outdated before you finish paying for it. This machine was the opposite of all that. It was built in 1944 to last 50 years of daily use. It was buried for 78 years. And it still works. The men who built this engine took pride in their work. They over-engineered it. They used the best materials. They made every part repairable. They wanted their work to outlast them. That's a philosophy we've lost. Modern manufacturing is about efficiency, cost reduction, and replacement cycles. Things aren't made to last. They're made to be replaced. But this restoration proved something important. The old ways still work. Patience still works. Craftsmanship still works. Respect for quality still works. This project changed how Mike saw his work as an engineer. Modern engineering is all about optimization and efficiency. But there's something to be said for over-engineering, for building something so well that it can survive 78 years underground and still function. And it's not just about the machine. It's about the knowledge. How many people today could do what they did? How many people understand mechanical systems well enough to diagnose problems, source solutions, and execute repairs without computer diagnostics or proprietary tools? This is knowledge that's disappearing. The ability to look at a machine and understand how it works. The ability to fix things with your hands. The satisfaction of bringing something broken back to life. But knowledge can be passed down. Robert Henderson, who rode this engine as a child in 1945, is now teaching his grandson how it works. The cycle continues, and the community has embraced the engine as a symbol of their agricultural heritage, a symbol of the men and women who worked this land, a symbol of a time when things were built to last. No one is suggesting we go back to steam power. Modern technology has its place. Today's tractors are more efficient, more powerful, more comfortable. But they're also more complex, more fragile, more dependent on systems beyond the operator's control. You can't fix a modern tractor with a wrench and determination. You need computers, proprietary software, authorized dealers. This engine? You can see every part. You can understand every function. You can fix anything that breaks with basic tools and mechanical knowledge. There's a freedom in that, a self-sufficiency, a connection between man and machine that's been lost in the digital age. Martha's grandfather wrote in his journal that this machine deserves better than the scrap heap. What he meant was that some things have value beyond their immediate utility. This engine represents the work of skilled craftsmen. It represents the farmers who depended on it. It represents an era of American manufacturing that we should remember and respect. This engine was built in Indianapolis by American workers using American steel during a world war. It powered American farms that fed American soldiers. It's a piece of history that deserves to be preserved. But more than that, it's a reminder that quality matters, that craftsmanship matters, that some things are worth saving, worth restoring, worth passing down to the next generation. In a world that's constantly chasing the new, the faster, the more efficient, there's something profound about a machine that's 80 years old and still works perfectly. It connects us to our past, it teaches us about our present, and it challenges us to think about our future. What are we building today that will still work in 80 years? What are we creating that our grandchildren will want to preserve? What legacy are we leaving? These are the questions that this old steam engine asks us, and they're questions worth answering. 6 months after its resurrection, the Harrison Type 40 found a permanent home at the Johnson County Agricultural Heritage Museum. The dedication ceremony drew over 300 people. Farmers, engineers, historians, families, all coming to celebrate a machine that refused to die. The engine runs on the first Saturday of every month. School groups come to see it. Veterans come to remember it. Engineers come to study it. For children growing up in the digital age, it's a window into a world they can barely imagine. A world where machines were simple enough to understand, robust enough to last, and powerful enough to change lives. Mike and James now teach restoration workshops at the museum. They're passing on the knowledge they gained during the 6-month restoration. And that knowledge is spreading. 3 more buried steam engines have been discovered in the region. 2 have been successfully restored. The 3rd is in progress. It turns out that William Henderson wasn't the only farmer who couldn't bear to scrap his faithful machine. Others buried them too, hoping that someday someone would care enough to dig them up. A network of restoration enthusiasts has formed. They share knowledge, source parts, and support each other's projects. What started with one engine has become a movement. The story has been featured in agricultural journals, history magazines, and engineering publications. A documentary film is in production. The Smithsonian has expressed interest in the restoration techniques used. Robert Henderson, now 76, Volunteers at the museum every Saturday when the engine runs. He tells visitors about riding on it as a child, about his grandfather's decision to bury it, about the day it came back to life. And his grandson, William Henderson IV, named after his great-great-grandfather, is learning to operate it. The knowledge passes down. For those who appreciate the technical details, here are the specifications. Harrison Machine Works Type 40 Agricultural Portable Steam Engine. Serial number 1847. Year of manufacture, 1944. Horsepower, 40 HP at 100 psi. Boiler type, locomotive-style fire tube. Working pressure, 100 psi maximum. Boiler capacity, 50 gallons. Fuel, wood or coal, currently operated on hardwood. Weight, 4.2 tons. Dimensions, 12 feet long, 8 feet tall, 6 feet wide. Flywheel, 6 feet diameter, 800 pounds. Operating speed, 120 RPM. Years in service, 1944-1946 original, 2024, present restored. Years buried, 1946-2023, 77 years. Current status, fully operational, demonstrated monthly. Current location, Johnson County Agricultural Heritage Museum, Iowa. But numbers don't tell the whole story. This machine is more than specifications and statistics. It's a connection to the past. It's a testament to quality. It's a challenge to the present. It's a gift to the future. Every person who sees it running takes something away. For some, it's nostalgia. For others, it's inspiration. For many, it's a reminder that we've lost something important in our rush toward the future. People ask Mike if it was worth it. 6 months of weekends, hundreds of hours of work, the research, the problem-solving, the setbacks, and he tells them, absolutely, because they didn't just restore an engine, they restored a piece of history. They proved that quality endures. They showed that some things are worth saving, and they inspired others to do the same. This project taught James something about engineering that he'd forgotten. It's not just about efficiency and optimization. It's about building things that last, things that can be repaired, things that connect people across generations. That's engineering with purpose. That's engineering with soul. Martha's grandfather buried this engine because he couldn't bear to see it destroyed. He hoped someone would find it and remember. Mike and James did more than that. They brought it back to life. They honored his memory. They honored all the farmers who depended on machines like this, and they gave the family a gift they never expected, the chance to hear the sound of their history. Robert is 76 years old. He never thought he'd hear that whistle again. He never thought he'd see those pistons move. He never thought he'd be able to put his hand on that flywheel and feel it spin. But here he is. And he's 5 years old again, standing next to his grandfather, learning about steam and pressure and the satisfaction of work well done. That's a gift beyond measure. For 80 years, this machine waited in the dark, buried, forgotten, silent, but it never stopped being what it was. A masterpiece of engineering, a tool of honest work, a connection between past and present. It took 2 engineers with curiosity, a family with memory, and a community with respect for the past to bring it back. And now it breathes fire again. Every turn of that flywheel is a connection to the men who built it, the farmers who relied on it, and the era when machines were made to outlast their makers. It runs on the first Saturday of every month. If you're ever in Johnson County, Iowa, come see it. Touch it. Listen to it. Feel the heat from its firebox and the vibration of its pistons. And when you do, remember, this is what quality looks like. This is what craftsmanship means. This is what happens when we refuse to let history die. Some things are worth digging up. Some things are worth saving. Some things never die. In memory of William Henderson, 1898 to 1972, and all the farmers who built America one field, one harvest, one faithful machine at a time. If you enjoyed this story of resurrection and craftsmanship, hit that subscribe button so you don't miss more incredible tales of history brought back to life. Give this video a thumbs up if you believe some things are worth saving, and drop a comment below. What piece of history would you dig up if you could? Your support keeps these stories alive.